Hey mathematicians, it's JP from Geeky Teachy. Today I wanted to make a video to introduce to you one of my favorite math tools, and that's blank lined paper. At the beginning of every unit, I always teach my students how I want them to use the blank lined paper for the concept that we're learning. And then throughout that unit, we practice using the paper and do all of our scratch work on paper. So we're going to start with place value, as that is really the key understanding that we need before we learn anything else. So for place value, no matter how young we are, kindergarten or fourth grade, we always start with our ones place. Okay. I always have the kids use the margins or the columns, the blue lines on the paper, for one digit or one letter at a time, especially for our younger kids who are learning how to write a lot neater and make their numbers and letters smaller and appropriately sized. This really helps to make their work nice and neat. So starting with our ones place, ones, tens, hundreds. Now, depending on the grade level or the age that you're teaching, you may or may not want to add the comma. I know for my fourth graders to start out, we do add the comma, but once they kind of get the hang of the concept, we drop that comma later on, as far as the place value chart goes, not when we're writing our numbers. So we have our ones, tens, hundreds, ones, tens, hundreds, ones, tens, hundreds, making up our periods. We then can label our periods. Okay. We can also do the same thing without the commas. So once your kids get the concept of place value, ones, tens, hundreds, ones, tens, hundreds, then we can kind of drop that comma and create our place value chart, labeling units, thousands, millions. Could even take it into the billions if we want to, as well as decimals. So tenths, hundredths, thousandths even. Now I don't teach this as often. Occasionally I'll teach students to draw their own base 10 blocks on a sheet of paper. I generally reserve this for students who are really struggling with addition and subtraction. So for our example, let's do 342. Let's add that to 135. So to start, we would draw the 342. We would label our place values. So I have 300ths. So I want to make these big boxes. So 300ths, I have 4 tens, and I just draw these as vertical lines on my paper, trace those blue lines, and then 2 ones, and I just represent that using small dots on the paper. Then for my 135, I have 100, 3 tens, and 5 ones. 1, 2, 3, 4, 5. And then we'll add up our ones, 1, 2, 3, 4, 5, 6, 7. Add up our tens, 10, 20, 30, 40, 50, 60, 70. And add up our hundreds, 100, 200, 300, 400. So I also use the line paper for number lines and rounding. So when we're starting to introduce number lines and rounding, I'll have the kids practice tracing on the pink line to create that nice, neat, straight line. And then we'll trace the blue vertical lines to create our tick marks on the number line. Once they get used to tracing this, and they do pick up on it very quickly, they can just draw a horizontal line going through the blue lines, add those tick marks, and then you've got an instant number line. You can use this for adding and subtracting, you can use it for rounding, you can use number lines for place value, decimals, all sorts of things, fractions. For rounding, I have the students, after we've created our number line, we label 0 through 9. And then we split down the middle, and anything above 5 we'll round up. Anything below 4 we'll round down. So for this example, let's round 325 to the tens place. Again, referencing back to the place value, we can label ones, tens, hundreds. We have our place value chart. We now know where the tens place is. We'll look next door. I teach my kids to circle the number next door because that digit is going to become a 0. Once they circle it, I'll have them bring the 0 down, leave the place value that we're changing blank since we don't know if it's going to change or get bigger, and then bring down all the numbers in front. So we are specifically looking at this 5. So going back to our number line, we find the 5. If it's past our halfway point, 5 or greater, that means we're going to increase our tens place. So coming back down here, our 2 is going to become a 3. So 325 is going to round to 330. So adding and subtracting is probably the most common way that we use the blank lined paper, because a lot of times kids will want to use scratch paper and they kind of do their work like at an angle, and then their numbers get messed up, their place values become misaligned. So for adding and subtracting is really where I push my kids to use the blank lined paper. So for example, if we're doing 5,241 and we're going to add that to 2,799, I always make them start in the ones place and fill in their numbers going to the left to ensure that their place values are lined up. Then we can go place value by place value, adding those up. We can also do this to check our work. So we'll take this 8,040, subtract 2,799. So notice the whole time, like when I borrowed, I made sure to keep that within the same column as the number previous to it. So I really push this on my kids so they keep their numbers nice and neat. When they borrow, they know exactly where it came from and where it's going. We can do this for decimals as well. I know in 4th grade especially, it's very important to teach them to line up their decimals when adding and subtracting. So if we started with, say, $50, we went to the store and bought something for $43.75. So we would have to borrow across zeros. So I do make them go and turn everything to a 10 before we can borrow from it. So again, when I do borrow, it is still within that same column. And we can make sure that our decimals are on the same blue line, make sure they're lined up. And then we can do the same thing, check our work, make sure our decimals are lined up. Trace that blue line, bring down the decimal. Could also use the line paper for multiplication. So for this example, I'll be using 18 times 3. So I know in the lower grades, we teach multiplication as repeated addition or equal groups. So we could do 18 plus 18, 8 plus 8 is 16, carry the 1, 36, so that's 1, 2 groups, we need one more equal group of 18. So 8 plus 6 is 14, carry the 1, that becomes 54. That's 3 equal groups of 18 for a total of 54. We could use this for equal groups. And we could do 18 dots. We could do 18 tally marks, whatever works best for your students, and then they could count those up. Granted, that really only works when we're working with smaller numbers. We could also use this for standard algorithm multiplication. We could use this for area model multiplication. And we could even set up a lattice model, lattice method. So lots of ways that we can use this line paper to make our work nice and neat. For a larger, I do want to show you really quickly for larger numbers using an area model. I generally tend to have my kids count 1, 2, or 3 columns over. So if they're doing like a 3-digit by 2-digit number, let's say they're multiplying 543 times 18, they could, do an area model. They could also turn that same square into a lattice. A lot of the same strategies we used for multiplication we can use for division as well. So I'll use 18 divided by 3. So we could use repeated subtraction, counting groups as we go. So 1 group, 2 groups, 3 groups, 4 groups, 5 groups, gives us 6 total groups. We could also do equal groups. So if I'm dividing by 3, I need 3 equal groups. And then I'm going to split the 18 into those 3 groups until I have none left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Each group has 6 in them. We could also just do listing our multiples of our divisor. So if we're dividing by 3, we would do 3, 6, 9, 12, 15, 18, 21, 24, 27. Notice that I've still, even when listing my multiples, I have them broken up by place value, my 1s and my 10s. And then I'm just going to write which multiple it is. 3 is our first multiple, 6 is our second multiple, 9 is our third, and then I would just list those going all the way down. We could also set up a grid method. So depending on how large your dividend is, is really determines for me how large my boxes are. If I have a 3 or even a 4-digit dividend, I may include 3 or 4 columns in each box just to give myself some more room when it comes to subtracting. 3 divides into 1 0 times. Bring that 1 up. 3 divides into 18 6 times. I'm left with no remainder but a group of 6. When those dividends get a little bit larger, so we're going to do 324 divided by 8. So if I'm doing grid method, I just want to extend out my boxes a little bit, maybe give them an extra column or 2 even. Once I get into the thousands and 10,000s, I'll probably need those 4 columns. So 324 divided by 8. 8 divides into 3 0 times. 3 minus 0 is 3. We're going to bring up the 3. Our new dividend is 32. 8 divides into 32 4 times. 4 times 8 is 32. Bring up those zeros. 8 divides into 4 0 times. And then I have a remainder of 4. For standard logarithm especially, I love using the lined paper. This is a very difficult concept for students, and so having some organization and knowing where to bring their numbers down, where to subtract, where to put the digits in the quotient, this lined paper is just magical. So 8 dividing into 3, I'm going to put the digit, how many times it can divide into the dividend above the digit that I'm dividing into. So 8 cannot go into 3, so the 0 needs to go above the 3. 8 times 0 is 0. Again, it stays in that same column. 3 minus 0 is 3. I'm going to bring down the 2, keeping it in the same column it started in. Now I'm dividing into 32. 8 divides into 32 4 times. The 4 is above the 2. 8 times 4 is 32. Line up my place values and subtract. Then I'm going to bring down my next digit, keeping it in the same column. It becomes repetitive, but it really is so important to just instill those habits into your students. 8 divides into 4, 0 times. 4 minus 0 is 4, so I have a remainder of 4. So I don't really push my students too much to use the lined paper for fractions unless they're struggling with finding common denominators. We might set up a T-chart or make sure that our fractions are lined up when looking for equivalent fractions. You could, though, use it to just draw their fraction bars. You could use it for adding fractions. You could use it for subtracting fractions. For finding equivalent fractions, just have them list their multiples of their numerators and the multiples of their denominators. For finding common denominators, let's say that we need to add 2 fractions with different denominators. Let's say that we're doing 3/4 and 5/12, and we want to find a common denominator for those two. We're going to go through and find our equivalent fractions. So list our multiples of our numerator, our denominator, and we found common denominator. You could even do comparing fractions. So if we did 4/6 and 5/7, you could use that for cross multiplication. Like I said, though, I don't really push the line paper for fractions unless they're really struggling with lining those fractions up.